When graphing linear equations, there's a number of different ways we can go about it. There's also two very easy ways. Sometimes they'll give you specific points they want you to plot, and other times you might have to use what's known as friendly numbers. Let's take a look at this example, y equals 2x minus 3. To plot this in this case, we're going to use what are known as the friendly numbers, namely -1, 0, and 1. These are the three easiest numbers to work with in terms of an x-coordinate and are generally pretty easy to find the values for and plot. Let's work with just -1 for right now. This is a two-step process to find the y-coordinate. Step 1, substitute the x value in. So, I'm going to take the equation and substitute in -1 for the x value. Y equals 2. I'm using parentheses to show that I'm substituting in the x-coordinate. Then the following step, you solve for y. 2 times -1 should become -2 minus 3. Just to do state change opposite to show it. -2 plus -3. In this case, y should equal -5. And it does. Now that we have two coordinates, we can plot this point. X is -1 and y is -5. So that point would be right about there. Again, to be able to draw a line, we need more than one point. So, let's clear our board and let's work with the next coordinate. 0 might be the easiest number to substitute in for x, because a lot of stuff ends up falling out. So, I'm going to substitute in 2, 0, minus 3. 2 times 0 is 0. So what I'm left with is minus 3, or -3. And that happens to also be my value. So I'm going to plot this point. Since my x-coordinate is 0, I'm not going to move to the left or to the right. And instead, I'll just move down 3 for the y-coordinate. So right about there. We can now draw our line if we choose to, because we have 2 points. But since we have to find one more additional point, we'll go ahead and find it. So the last value to substitute in, the last friendly number, is 1. So I'm going to substitute it into my equation. And again, it helps to use parentheses to show where you're substituting it in. 2 times 1 equals 2. Minus 3. And I'll do state change opposite. 2 plus -3 works out to -1. There we go. So we will plot that point. X equaled 1 and y was -1. You can still see the straight line that we're forming even if we were to add additional points. I'll connect these 2 points to show. So if I were to use other points, for instance, I could probably expect the point 2, 1 to be on this line. And we can check that real quick as well. So, according to our graph, 2 and 1 should be a point on this line. Let's check. Our y value in this case is 1 equals 2 times 2 minus 3. 2 times 2 is 4 minus 3, which is 1. So it checks out. In this example, they're giving us 3 x-coordinates that they would like us to plot. So instead of being able to pick friendly numbers, we have to work with what we're given. Let's start with the first number, in this case the x-coordinate of -2. We still follow the same steps as before. We're going to substitute in our -2 in this case at 4, and then we're going to solve for y. Please remember, that negative on the outside is really like saying -1 times -2. That could change your problem depending on how you go about it. -1 times -2 should work out to 2 plus 4, and our y value in this case should be 6. And it is. So I'm going to go over here, -2 for the x-coordinate, so I'm going to go backwards 2 spots, and then up 6 for the y-coordinate. And I'll put my point right about there. Now we still have to plot the other two. Okay. Let's work with 0. Again, 0 is generally the easiest of the numbers to work with. So here we have -1 times 0. Since 0 multiplied to anything is 0, it's just going to drop out, and we're left with 4. So, we're going to plot 0 and 4. And that actually works out. One final number to plot. We have substitute in 3 plus 4. Again, this is just like saying -1 times 3 plus 4. -1 times 3. A negative times a positive is a negative, and 1 times 3 is 3. Add 4, and this should work out to just 1. And check, and it does. So I'm going to plot the point 3, 2, 3, and 1. If we wanted to, we can go back and check to see certain values. For instance, we could go back and plug in 1 for the x-coordinate and solve for y, or we could plug in 4, but they should all be on a line connecting these 3 points.